Then now it's just crying.
We had this sexist conversation, me and Paul.
Let me get you a
Is it-
sexist one.
Is it true that all handsome men want housewives? Yes or no?
No.
That is false.
You're supposed to.
Whose claim was that all handsome men want housewives?
No.
His claim.
No,
He is sexist.
Like, we were having a conversation about how women should stay in kitchens.
What was Fawan's opinion of that?
She liked it.
No.
She was gonna stay in the kitchen. But
No.
The only problem is she can't, because the fastest way to a man's heart is his stomach.
Or something else.
Yes. Thank you for finishing that for me. I was not in a position to.
But it's not mean the wife had to go to the kitchen.
Of course it does.
Look. He comes from the Middle East. It's a different culture, a different society.
My mom works, my grandmother worked,
Good.
my aunt works. Actually, most of the females in my family do.
Good.
So,
Yeah, I forgot, what's your hometown?
well, I was born and raised in,
Yeah, born and raised, yeah.
but I'm from Palestine. In Palestine, it's different.
Well,
It's quite different, but you're born and raised, so your upbringing was where? UAE, okay. And they are Western compared to their neighbours, like say Saudi Arabia, for example.
No, the locals are more strict than every other.
The locals.
The locals, yeah.
No,
yeah.
when you think of the Middle East, you usually think of the Gulf. Like when people in here think of the Middle East, they think of the Gulf. They don't think of the other countries, like Lebanon, Palestine, Syria. They're
No, I wouldn't say that's fair to say in Ireland. A lot of people would have places like Palestine on their radar.
yes, but then they wouldn't know how Palestine is. They expect it to be because most of the people that whenever anyone asks me where I'm from, I have a huge conversation. They just start talking to me, and I go, shouldn't have said that.
Can you just say Middle East and leave it at that?
Where from the Middle East? Saudi Arabia.
You say Dubai?
You say Saudi Arabia, they look at you.
Yeah.
Oh, he's balding. I was like, not rich.
So what do you mean people have a different opinion of Palestine? Can you tell me
They think,
Palestine?
when you say Palestine,
Yeah.
they usually think... no, they think that you are... You hate Jews. First of all, that's the first thing that pops in their head. And you're Arab, I guess, or... But then some... No, you're Arab.
Interesting.
But then
I would never guess that.
But then their definition of Arab is always Muslim.
Yeah, no, I
But
get
then
that,
what
yeah.
they don't know about Palestine...
No, I know, I understand that, yeah, and that's something I remember saying to someone before, saying, just because they're Arab, doesn't mean they're Muslim,
Yeah.
other possibilities too.
Some countries, like some Arab countries, they're only Muslim.
Yes.
But then in Palestine, that's not the case.
But still, there isn't any Arab country that only Muslims live in.
Yeah.
There isn't any Arab
But then-
country only Muslims live in.
Oh, yes.
Yes.
Except for Mecca.
Like the Gulf
Mecca
countries,
is
it's
a
a city.
It's a city.
I'm pretty sure there are foreigners in Mecca.
Yes. But no.
One or two, maybe.
In the Gulf, all the locals are Muslim, yes.
Yes,
Yeah.
the locals are Muslim.
Yeah.
But then not the people living in there.
Yeah.
But
that's only in the Gulf.
only in the Gulf. Like in Iraq.
Outside of the Gulf, all the countries have at least 2 or 3.
Yeah, like Andrew.
At least.
And I'm Muslim and he's Christian, right?
Yeah,
And we're Egyptian.
and in Palestine it's Muslim.
What
Christian.
percentage of the Egyptian population is
We're
Christian?
mostly minority.
I figured minority, but what percentage? How minority is the minority?
But no, there are a lot of Christians.
Are we talking 10%?
No,
More or less?
More than that.
More than 25.
Less than a quarter then, yeah, okay.
But then there are eight.
So that's still a significant minority.
About 100 million.
Yes, yes. It's a lot of numbers. Yeah.
And in Palestine it's Jews, Christians and Muslims.
Yeah,
But
the same
still,
part.
for some reason, it shocks
I know.
everyone that I am Christian.
But then he still gets treated like a Muslim.
You need to be
I get
walking
the
around.
racism from
You
both
need
sides.
you need to be walking around with like a giant cross on you or something, like, or you know, I Heart Jesus T-shirt or something. You know.
Either way, I get racism from both sides.
Yes. Yes.
What? Oh, we're doing math now.
We are doing maths because we just had physics. Yeah.
Oh, yeah. You need to change books.
Yes. Please activate your brain to max mode now.
No, wow.
No.
And you notice nothing happened for Lee. It's the same mode for both. We're doing maths now. Great.
More numbers.
Same copybook? That's different. I didn't see you change it. It's different. There's no physics in that? Really? Show me.
Chinese power.
I am worried that this is how much maths you've made since you started.
Not the quantity, it's the quality.
Must be good quality maths. Wow. Okay. Last time we were looking at product rule and quotient rule, and we're looking at the third of the three rules for this is the chain rule. Interestingly, in the syllabus and in some maths books, they recommend that you do all three rules in one lesson, which I feel is
Too much.
I don't know whose idea that was. So I break this one topic into three: product, quotient, and chain. Chain is the third of the three rules we're looking at here. So just as a quick refresher from the last one, I'll just give you something quick to differentiate using the product and quotient rule then. So let's just go with EX over X log X. Differentiate that. Oh, we got the light. You think you're in a minority. I'm even in a more of a minority here. Because you're, what's it, 10, 11, 12%? But I'm Protestant, which is like 1%.
Correct, but I'm Protestant Egyptian.
Oh, right, okay.
So that makes me like 1%.
Yes,
Of the 25%.
The competition.
Okay, alright.
I'll get it started.
Alright.
Set aside countrywide.
That's even smaller percentage then.
Like usually, all my Egyptian Christian friends, they usually have a cross tattoo to the wrist.
Really?
Yeah. It's Andrew told me that it's something to do with history or history. But then Andrew's the only Egyptian Christian that I've seen without that cross.
So I'm like 1% of the 1%.
Andrew's special. Alright, we got it here, so what's first?
Isn't the main
Yeah.
Protestant church is in Alexandria in Egypt?
Oh, no, it's too complicated. There's too many churches. There's no main Protestant church.
Like was the first Pope?
Pope is Catholic.
Yeah.
And what's the...
There isn't one really. There isn't.
Then what's really huge in the Alexandria in Egypt that's related to Christianity?
Coptic Christians maybe?
Yeah.
I don't know.
Yeah. They might, Alexandria might have just the old
Yeah, that whole
Protestant,
thing.
yeah. But it's certainly not big by any standard. Yeah.
But there is some historical value in Alexandria for Christians.
Yeah, probably Coptic.
Mm-hmm.
Yeah. I don't know. I think it's Coptic is the name of it, I think.
We call them Akhbar in Arabic.
As Coptic?
Oh,
Yeah.
okay.
Bottom times derivative of the top. And what's the derivative of the top? EX minus the top, and then here we have what rule next? Product rule. So that's 1 log x plus x times 1 over x. Okay, good. Now, when do we need the chain rule? So let's have a look at when we need the chain rule. Chain rules come when we have problems like this. E power sine x. Or maybe something like this. Sine x squared. Or maybe something like this. 2x plus 1 cubed. Or something like this. Log sine x. What is in common?
X, Y, Z.
No.
Sine, why not
That's a product rule.
no. S equals X, Y, Z.
But that has 3 variables.
Yeah.
No?
So
Like
you
this
can
one.
change it.
I don't know what you're asking me. I'm just going to ignore that. It's easier.
Ouch.
What is in common to my 4 examples?
Logs.
No, log is not in everything.
Like, I mean,
X.
powers, logs.
Except for the obvious. What's in common to the 4 of them?
There's more than one type of
Get you? Yeah. But
complex equations.
not quite the right word. But product rule, compound is closer. Product rule has more than one type. It's like x by sine x. So what is different here, though, to a product or quotient?
We don't know, tell us.
No, you might be able to see it, no? Well, they don't all have powers.
You are mixing 2 types of.
Yeah, but the key is how am I mixing? How am I mixing the 2 types? That's the key.
You're putting one inside the other. Yes.
That's it. So in all of these examples, there's one function inside of another function. So for example, here the sine x is inside the e. Here the x squared is inside the sine. Here the 2x plus 1 is inside the cubed. And here the sine x is inside the log x. These situations require the chain rule. And I will give you the chain rule now. Okay, can I scroll down? Not yet? Yeah, I think these are good examples here. These need the...
But we can also use the chain rule for any product rule.
Not really, because product is not the same thing as a chain.
Yeah, but we can use the chain for like fx equals xy.
Yeah, we will do examples where...
They're multiplying with each other.
Oh, no, not really. Chain rule is really just one in the other.
Not each other together. All of them like each other.
That's
Grammar is very important.
Yeah. Sorry. I can have cheeseburger. Right. Okay. Let's have a look at the chain rule. So there are 2 ways to do this. When I show students one way and then show them the other way, they're like, oh, the other way is better. And when I show them the other way and then show them the first way, they're like, the first way is better. So I'm just going to show you both ways, and you decide which way is better for yourself. So the first way is by a formula. The chain rule formula is this: dy dx equals dy du dx. And the proof is actually pretty simple because the du's cancel and we have dy dx. End of proof. So let's have a look at an example of how this rule works. Let's say something like y equals sine x squared. So what you do is first you make u equal to the inside piece. So
What's
here
the y of the formula before?
dy dx equals dy du dx. Huh?
Y equals what? And then
Oh no, this is the formula for finding dy dx. I'll show you, watch. So say we have y equals sine x squared. What you do is you let u equal to the inside piece, x squared. Then you calculate du dx. What's the derivative of u here? 2x. You have y equals sine u. What's the derivative of y in the u case?
Cos.
Cos u. So using this and this, dy dx is dy du multiply du dx. So what's dy du? Cos u. Multiply by what's du dx?
2x.
What's left to do is change it all back to x. So this will be cos,
X squared.
yeah, multiplied by,
2.
so this is the derivative, dy dx here. So we get it by using a formula. I will give you one to try, and then I'll show you the other way. So please write this down as our first example.
So how did you turn u is x okay.
I can do a trick.
No, don't, because the trick might be the second method I want to show you. Probably is. Okay, can we go down? Yep. Right, using this method,
Could you do it on the same question?
what do you mean?
The same
On
question.
y is equal to sine x squared.
No, I'm not showing you, yeah, I will show the second method on the same one, but I want to give you one to try using this method. So, just to practice, I want you to differentiate e sine x.
So the u can be any.
No.
It's the sine
Must be the sine x here. Why?
because it's after.
Because it's on the inside. Really? Did you do it the way I want you to do it? Did you? I guess I believe you, but I don't really. Finished, Faisal? Did you do it the way I wanted? That's a no. Yep. What, Juan, what answer did you get? Go on, what you got? Yeah, that is a weird answer. That's wrong. What did you get, Yusuf?
E to the power of sin x times cosine x.
Correct. Juan, what did you get? No.
Wrong.
Let's have a look. Please write this down carefully, especially if you got it wrong. Look. So we start off by saying u equals
Sin x.
sine x. U equals sine x. What does du dx equal?
Cos x.
Cos x. Here y equals eu. What does dy dx equal?
EU.
EU. So we have this result and we have this result, and the formula is dy dx, sorry, that's du here, equals dy du, du dx.
Isn't it supposed to be u eu?
Yeah.
No.
EU.
That's
No.
differentiation.
What's the derivative of ex?
But E
No, it's not.
That's
different than
okay,
yeah.
Yeah, ekx, the k is 1 here.
It is one.
EU times cos x, which equals e sine x Cos x. Okay, I'm going to give you another one since that was rather unsuccessful. Look, I just have to work with what I have in front of me. I'm sorry. Continue. Continue. Right, try this one, please. Y equals log sine x. Finished? No thinking, just mathsing.
Yeah, I'm thinking about this.
Okay. Right? Yeah. Correct. Very good. Now we're getting it. Okay. So, what do we let u equal to?
Sine x.
So this is log u because u equals sin x. What is du dx?
Cos x.
And what is dy du? And so dy dx, we multiply these answers together. 1 over u cos x. So cos x over u. What's u? Sin x. So this is 1 over tan x. Or, if you prefer, that is also called cotan x. Yeah? Right, now that we've cleared up that method, let's have a look at the second method. You need to write this down? Got it? Okay. Second method you'll like. Let's go back to our first example of sine x squared. Now watch carefully. What you do is you identify what is the inside and what is the outside. So here the outside is sine and the inside is x squared. I'll say it again. The outside is sine and the inside is x squared. And the rule is you differentiate the outside and then you multiply by the derivative of the inside. And that's it.
Same thing.
Yes, I know, it should be the same thing because it's the same question. So it should have the same answer. Right?
No, but it's just the formula you gave us before.
I know.
Words.
In words, in beautiful, simple, quick words. Right? So, let's try it with this one. Y equals E sin x. What is the inside? What is the outside? So what is the outside?
E.
And the inside?
Sin x.
So the derivative is differentiate the outside derivative of E. E. And differentiate the inside.
Both sides.
Log sin x. Differentiate the outside. What's the derivative of log?
1 over x.
So 1 over sin x. And differentiate the inside. Getting the idea? Hey, Faisal, focus here.
I'm here, Facebook.
So tired. So very, very tired. Can I scroll down?
30 seconds.
Yes, I need it. dude, just don't hide it. Just take it out and eat it. What is it?
I don't want to have
Chocolate. Probably.
I don't need chocolate. I had loads of chocolate today, thank you.
Free chocolate?
Free chocolate. Yep. Right, try this one for me. It's a little bit trickier now. See what happens.
So the second method?
Whichever one makes you happiest.
Give us free.
Could be what?
Free. Those are two free. Give us free functions.
Yes, I'm going to build them up. Don't worry. It's like I know what I'm doing. But not really, it just appears that way. Yes, I think so. Yes, it's a trick really. Too easy for you, Fawn? Alright, do we all have an answer?
Yes.
I will use the quick method. I will change this in the sin x power a half. This is the inside and this is the outside. Differentiating the outside. Bring down the power, reduce the power by 1. Differentiating the inside. So if you want, the answer is cos x over 2 root sin x. Yeah?
Can we leave this no?
Yes. We is smart. We is smart.
Why not the square root is outside and the sine is inside?
Huh?
That's the case.
Why is what?
I change this to
I didn't understand. Say again.
The square root
Yeah?
is outside.
square root.
Oh, why is the square root the outside?
No.
Mm.
In the first.
Yeah. Here.
No.
Oh, here.
Yeah.
Yeah.
The square root.
Yeah. It's outside. Yes.
Why you have to change it to 1 over 2?
You don't have to. I just like to. It makes me happy.
Let's make like modifier.
Which makes me happy. Okay, you have this one? Let's start making them a bit harder now. So try this one. What rules do you need here?
Now we are talking.
Yeah, now it's getting interesting. We need product and chain. And you know what will be coming soon.
Interesting.
X minus x to the power 2.
E to the power of minus x squared sin x. good. Finished?
Yes.
Successfully?
Yes.
We'll see. So, what rule do I need first? Product or chain?
Product.
Product. So first, it's the derivative of e minus x squared, which is a chain rule. Differentiate the outside, which stays the same because it's e. Multiply by the derivative of the inside, which is
Minus
2x. Times sine x.
Plus.
Plus e to the minus x squared times derivative of sine x, which is cos x. Since e is in common, you may wish to take it out, and you're left with cos x minus 2x sine x.
Yeah.
Did you get this, Faisal?
Yes.
Yeah. Good. Okay. You knew this day was coming. Y equals sine x squared e minus x squared over square root x log sine.
Are we making another partition?
No, because the word minus doesn't repeat enough here. Because in the last one we had minus, 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 minus. That doesn't happen here, I'm afraid.
How did you scroll up the last part?
You can do it. What?
Simple but complicated.
Yes, simple but complicated. Yes. Yeah.
I used to change every quotient rule to a product rule by making times 1 over 1.
Yeah.
What?
And then you have to change that to a chain rule. Correct. Lee, please do not distract Andrew. He's trying to do this one. Yeah.
Do we get questions like these in this now?
No.
Yes.
No.
Yeah.
I thought so.
This is just for our entertainment. I mean education. Be strong, Luan. Be strong. Think of the basketball player.
I'm not gonna do that. I can't. Do we first
No,
use the
Chase,
chain?
you can.
Too much.
It's not.
We first use the chain rule then.
Nope.
No.
Mm-hmm.
And then we have to.
It'll be quotient product chain most likely.
I'll have to differentiate the denominator.
Yeah.
Oh, no.
No, I'm not doing that.
It's only a product and a chain.
1, 2, 3, 4, 5, 6. For the numerator.
Nice.
Function.
Nice.
And 1 denominator. That's it.
Faisal. You did it, Lee?
No.
Come on, be strong.
U over this C minus Oh my god. Oh.
Finish?
Chain rule applies as many times as possible. FGH.
That's not what I have done.
Oh, you mean something inside of something inside of something?
Yeah.
It gets messy, but yeah, you can go through it like this. Yeah, maybe we'll do an example of that next. I'll do one. No, I'll do it. Just relax, I'll do it.
I apologize.
I'll do it, because it actually, it could come up. I think there is some questions in the workbook on that. Okay, let's have a look at this one. Wait, okay, I'll wait. Yusuf, you've given up?
Yeah.
Now you see, if you stuck with it like Lee, look how happy he is. Yeah, you got it? Okay, let's have a look. Alright. Doesn't take that long.
Cos over sin is tan.
No, cos
Sin over sin. Sin over cos is tan.
yeah, and sine over sine is 1.
Yeah. Sin over cos is tan. What do I do when I have so many functions multiplying? I can use product. No.
Can I do it now?
You want to?
The bottom squared. The bottom times the derivative of the top, which is a product rule. First we differentiate sine. That will be 2x cos x e minus x squared plus minus the derivative of e minus x squared. So that's minus 2x e minus x squared sine x squared. Minus the top. Yep. I lost my square. Thank you. Minus the top times the derivative of the bottom, which is a product rule. So derivative of root x, bring down the power, that's 1 over 2 root x log sine x plus root x, and then we did log sine x earlier, we got 1 over tan x. Am I finished?
Yeah.
Oh, okay.
Cancel out.
Sorry, it was so easy I didn't realise I finished.
Was that the call?
But you
Of
not
sorts.
reduce it.
I didn't say to reduce it. Did I?
But
And that's an important lesson, because in the exam they do not expect you to simplify. Do not. Do not simplify.
By simplifying, you're just wasting your time, right?
Especially when they don't ask you to do it and give you marks for it. You're wasting your life. Okay, one more example and then we'll have a look at the workbook. So, let's do a triple chain. Sine of log of cos of x squared.
That's not triple anymore.
Whatever it is.
So what's
It's a triple.
what's in the ln? Oh, no.
Clear? Sine of log of cos of x squared. Ready? Scroll down.
Wait, let us try.
Oh, you want to try it? Really?
Why not?
Yeah.
Oh, why the heck not? Okay, give it a try. Got it? So do you have it finished?
Yeah,
Is it right?
hopefully. I believe in me.
Good. Right. What is the outside function?
Sine.
Sine. Derivative of sine? Cos. What's the inside function?
ln. The most inside? or
No. The next inside.
ln. No.
Log. So now we want to differentiate this.
Yes.
Which,
1 over cos x squared.
yes, because it'd be 1 over cos x squared. Cos x squared. Right?
No, why
No.
cos x squared again?
Yeah, why? Hang on, I'm getting confused.
Yes.
Right,
Okay.
I'll do it, but my train of thought will be broken if it's interrupted. So we'll just start. So first we have a sine. We differentiate the sine and we get cos. But what we have to do next is multiply by the inside derivative, which is the derivative of this. So the derivative of this requires a chain rule again. So that would be 1 over cos x squared. And we multiply that by the derivative of cos x squared, which requires a chain rule again, which is a sine x squared multiplied by 2x.
Minus.
Cos becomes minus sine, doesn't it?
Yeah.
Yeah, so the final answer will be minus 2x sine x squared cos of log of cos of x squared all over cos of x squared. Actually, which I could simplify down to finally minus 2x tan x squared cos of log of cos of x squared.
Yeah, I got it.
Isn't it minus sine x squared? Like,
Yes, it is. That's why I put the minus
Almost
here.
done, so it doesn't
Oh.
matter where I put the minus.
Okay. There we go.
Can you explain again the first one?
So that is good.
No, I can't.
Yeah.
But cos
Yeah,
L and
don't
cos x
simplify.
squared multiply 1.
Yeah, I just did it for fun. Huh? Second? What?
He didn't hear it. Repeat.
Never mind.
Oh, okay, fine. You can watch the video again if you like. Okay, so for the last few minutes, can you try some questions from the workbook, please? some blanking questions in the workbook, please, for a few minutes? Thank you. Can I close this one?